Hey guys, in today's video we're going to work through a bunch of problems taking the derivative using the definition of the derivative. These 5 problems represent the easiest to hardest types of problems you could see asked on your exam. So if you master these 5, you'll have the skills and the basics to ace this type of problem. So the first problem we're going to go through is taking the derivative of a constant. So this is the same process of taking the derivative of any constant like 0, 1000, or even pi. The answer is going to be the same. So when they say f of x plus h, they really just mean out of this formula f, everywhere you see an x on this side of the equation, we're replacing the x with x plus h. But in this case, there's no x's on the right side of the equation, so f of x plus h simply equals 2. And f of x is always given as the problem statement, which also equals 2. Meaning we can plug this in now to say f prime of x equals the limit as h approaches 0 of f of x plus h, so 2, minus f of x, also 2, over h. That's 0 over h, which equals 0. So again, this applies for any constant. Next, we'll move on to a slightly harder problem. So jumping right in, f of x plus h. Like I said, we're going to plug x plus h in every time we see an x. So 2 x plus h minus 1. That simplifies down to 2x plus 2h minus 1. And like I said, f of x simply equals the problem statement. It's given. So again, we can plug that in. F prime of x equals limit as h approaches 0 of 2x plus 2h minus 1 minus 2x minus 1. I would strongly recommend you use parentheses here so you don't mess up any of the signs. So that simplifies down to 2x plus 2h minus 1 minus 2x plus 1 over h. And the goal here is just to get as many terms to cancel out as possible. So we can cancel these, and we're left with 2h over h, which just gives us 2. So this one's a bit trickier, no worries though. Pretty much we're just wanting, like I said, to cancel out as much as we can here. So first let's define f of x plus h. That's x plus h squared plus x plus h. And a great trick to remember is every time you end up with a squared term, you're going to want to FOIL that out just to help you simplify things later on. So plugging all that in, so then we can cancel out these x squareds, we can cancel out an x, and we're left with this. So you want to ask yourself, how can we simplify this down further? So you'll notice that we can factor out an h on the numerator. Which allows us to then cancel out the h's as so. And we want to plug in limit as h approaches 0 to 2x plus h plus 1. That equals 0. And we're left with 2x plus 1 as our answer. So jumping right in once again, we want to define f of x plus h here. So this one looks a little more complicated, but just like the other ones, we're really just trying to cancel things out. So let's see what happens. f of x plus h equals the square root of x plus h. And f of x is simply square root x. So now we plug all that in. Limit h approaches 0 is equal to root x plus h minus root x over h. Now, this is a very common outcome that'll leave the majority of your class stumped, but all you need to remember in situations like this is you just need to multiply the top and the bottom by the conjugate of the numerator. And all that means is multiply by the numerator with just the opposite sign. And at this point, if you get this far, I think, in my opinion, it's just a matter of if you take your time and make sure you don't mess up this FOIL here. So we're going to FOIL this out. Root x plus h times root x plus h is just simply x plus h. Then we have negative root x times x plus h plus root x plus h. And then negative root x times positive root x is simply negative x. And we have h times root x plus h times root x. So now it's up to us to just see which ones cancel out. So at first glance, we can cancel out an x on the numerator. We can cancel out these two terms. And then down below, we can factor out this h. Which finally leaves us with 1 over root x plus h plus root x. So then finally plugging that in as the limit of h approaches 0. That goes to 0. We are left with 1 over 2 root x. So lastly, we come to number 5. This is the last type of problem you'll see and probably the most complicated, but really it's similar. All you have to do is know the tricks and you'll be good to go. So f of x plus h equals 1 over x plus h. And then f of x is simply 1 over x. Plugging that in, we get 1 over x plus h minus 1 over x over h. So when we have fractions in the numerator like this, all we need to do is just subtract the fractions, which just means you need to find a common denominator between the two and do some multiplying. So we're going to multiply this one by x plus h over x plus h, and we're going to multiply this one by x over x. Simplifying that further gets you x over x squared plus hx minus x plus h over x squared plus hx. So as you can see, that's the common denominator there. So we can simply subtract the numerators. X minus x plus h over x squared plus hx over h. In other words, that's h over x squared plus hx times 1 over h. So now we can easily see these h's can cancel out. And the most simplified version of this is going to be 1 over x squared plus hx. Finding the limit as h approaches 0, we're just going to plug in 0 for h. Finally, giving us our answer of 1 over x squared. So I'd like to leave you guys with these helpful tricks as a summary of what we just went over. So basically, we're just trying to simplify this formula until we can't cancel anything out anymore. If it isn't obvious what to do next to simplify this formula, you'll just have to do one of the first 3 things I listed here. Either square it out, multiply the top and bottom by the conjugate, or subtract fractions with a common denominator. You know you're done canceling out when there are no h's left. That's when you have your final answer. So I hope this was helpful, you guys. If you understand these 5 problems, I have no doubt you'll have one less problem to worry about on your exams. If you like this video, please like and subscribe so I can continue helping you crush your calc exams. Good luck, everybody, and see you next time.